Hello friends, welcome to another exciting episode of Mr. Johnson's Math Class. On this lesson we are discussing pyramids and prisms. Alright, before we get too far into this lesson, let's discuss a couple of key terms. The first one is polyhedra, and you can think of polyhedra as a solid, and here we have examples of different polyhedra. It's really just a three-dimensional figure. So you can see we could spin this one around, and a cube is a polyhedra or a three-dimensional solid. A pyramid would be a three-dimensional solid or a polyhedra. So it's really just a three-dimensional figure with width, depth, and height. And these are considered polyhedra because they have width. So how wide would it be? They have depth. So if you could see through this, and I'll show you, like if we spun this around, the depth would be this part that goes to the back. So this part back here, like how deep it is. And then if it also has height, so how tall it is. So if we were to stand this up, how tall it is. So like from here, the ground up would be how tall it is. And the same with our pyramid over here, from here down to its floor or to the base of it, that would be the height of the pyramid. A prism is a three-dimensional object with two congruent parallel bases. So this is an example of a prism that you see here because it has two congruent bases. So there would be a base, and then on this side would be a base. So a prism is anything with two bases, and that's really important. So you probably want to make a note that a prism is an object with two congruent bases, and the bases are parallel. And a pyramid is anything that really, you can think of it as like coming to one point or just having a top. So it's got a base, and that's this part that you see here. That would be the base. And then it has an apex, or it comes to one vertex at the top, and that would be, let me color it real quick, that would be this point here. So that would be the top of the pyramid. And that's really the main difference, or the big difference between a prism and a pyramid. All right, a few more key terms for us here. We have a vertex, and a vertex is where edges meet. So where two edges come together, they form a vertex. So you can think of it as like being the sharp point. So like if this were a box, it'd be like the sharp point on it. And a vertex is where two edges meet. So if two edges come together, they make a vertex. And the next question you might be asking perhaps is, well, what is an edge? All right, well, this is an example of an edge. This is an example of an edge. This is an example of an edge. An edge is where two faces meet. So if two faces come together, they make an edge. And it's just a line segment. Oh, not a very straight line there. But the line segment where two faces meet. And I guess that means that the next logical question is, well, what are faces? Okay, well, the face is the flat surface of the polyhedra, the flat surface of the solid, the three-dimensional figure. So that would be a face here. Let's see, this would make a face. So it's the space in between the vertices and the edges. And then this would be a face here. All right, last thing about some key terms that we're going to discuss. And that's how we name a solid, or how we name polyhedra. And solids are named by the shape of its base. And the base is not always what it's resting on, so don't think that it's always like the bottom of it. So here we have an example of a triangular prism. And there's a difference between a prism and a pyramid. So first, let's discuss the difference between a prism and a pyramid. So prisms have two congruent bases and they are parallel, and that's really, really important. So here you see a triangular prism. So there's one triangular base, there's one triangular base. And I'll try to turn this so you can see it has two parallel faces. So a prism is going to have two parallel faces, and that's really, really important. And then you have pyramids. All right, so a pyramid sometimes kind of looks like a prism, but a pyramid it only has one base, and the base is perpendicular to the height. So if, like here we have a pyramid, and if this were the height of the pyramid, the height would make a right angle. And the base, and in just a second I'll spin this around so that you can see. So just pretend right now that you can see that. But if we were to look at this, you can see that base. There's the base, and it would be perpendicular to the height. So you can see it there. And a pyramid has an apex, or it comes to like one singular point at the top, and it comes to a vertex. So if we had to name these solids down here, the base, and that's the first thing you want to look at is, well, what's the base? And the base, again, are the two parallel faces. So here's a base, and then here is a base. They are congruent, because remember it says up here they are congruent and they're parallel. And since it's got 6 sides, this would be a hexagonal prism. It's a prism because it has 2 bases, and it's hexagonal. It's got a hexagon for the base. For this next figure, it's a prism. It's a very specific type of prism. All of the bases on this one are all the exact same shape. They are squares. So you might think, well, gee, that must be a square prism. And it is a square prism, but a square prism has a very specific name. This is a cube. So if it's a square prism, we call those cubes. And then over here we see an example of a pyramid. And we have to first figure out what's the base. And by looking at this one, if we look over here, the base is the part that is perpendicular to the height. And I know this one doesn't have a height specifically sketched into it, but if we were to drop a height down on this one, you would start at the apex and it would go down perpendicular to the base. It has a triangular base, and since it only has one base, not 2 of them, it's only got one, this is a pyramid. So this would be a triangular pyramid.